Welcome to the lecture series. In this lecture series, we are going to discuss about an advanced microprocessors, that is MSP430. So let us discuss about the architecture of MSP430. So this is comes under the family of 16-bit ultra low power microcontrollers from the Texas Instruments, and the key features may include it is 16-bit RISC architecture, so it belongs to the RISC type of architecture, and it can have the ultra low power consumption. Since we have discussed about the basic microcontrollers and microprocessors, but we mainly focus on the four factors like area, delay, power. So these are the major factors which we focus on redesigning the ICs or redesigning the architectures. So first one is area, that is it has the capability of 16-bit and it is a RISC reduced instruction set, so it uses the minimized inbuilt area. And next one is power. Coming to the power, it uses the ultra low power consumption and it has the low power modes also. So the power consumption is also very low, and all other the peripherals which we are interfacing it also uses the low power modes, and it has a faster wake up from the standby modes. So faster wake up means it the delay produced by the processor or controller is minimal. So we have the pictorial of our MSP430. So you can see the onboarding interface facilities here, and you can see the pins, data pins, external crystal pins, and we have the socket here, and we have the power pins which can be used for the purpose of board power, and we have the reset pin, user LEDs, and user button. If we have to reset, we can go with the software side, but if the software side we are not mentioning, we can use this user button for the reset purpose. And we have the input output pins here, and we have the onboard power supply also. So we have external power pins and also the onboard power supplies, and we have the socket for the USB port. So this is a pictorial of picture of our MSP430 available in the market. So this is an internal architecture. So coming to the core components, we have the 16-bit RISC CPU. As we have the 16-bit RISC CPU, it consists of the registers for the memories, next flash, RAM, and coming to the watchdog timers, we have timer A1, A2, and also we have watchdog timer, and we have interfacing purpose, we have SPA and I2Z, and we have the input output ports for the P1 and P2. And coming to the external crystal pins, we have X in, X out, and clock acknowledgement and clock simulations, and model clock, that is mock clock also we can determine, or we can determine it as a multiple or more type of clock. So whatever we have when we have to perform a multiple task, we can change our clock accordingly. So coming for the empathize, why we have to use this MSP430 when compared to the other microcontrollers is, first main topic is understanding of the low power requirements. So whenever we are in the phase to redesign a microcontroller, first we focus on the power consumption, because if the microcontroller occupies the more power, then the other components may also require the more power. So that comes a bigger component of the battery. So what here we are focusing is mainly power source. So MSP430 gives a very low power requirement also when interfacing. And next is we have the pictorial of the IC, that is pin out. So we have VCC, and usually we have ground, and here we have the oscillators, VSS, and clock for the crystal oscillator clocks. We have reset pin and port 1, port 2 for the clock acknowledgement and internal clock. And we have the timer circuits here, that is TA1, TA2, and TA clock. So these are the timer circuits. Apart from this, we can use this port 1 as your input output ports also. And coming to the ideate, so where we have to develop this, so what purpose we can use this for MSP430 is, based on the functionality and based on the performance, we can choose this controller. If you want to be a real-time, standalone, networked, or mobile, So I have to design what is my application is and what should be my performance scale. So depending upon these calculation, I can go for the design approaches of the application with respect to the MSP430. And developing of a prototype is, we basically whatever the application may be, we should start with the design stage. After design stage, we have to go for the graph structures or input output interface requirements, and once the data is collected, we go for the implementation. Once implemented, we have to go for testing. So without the testing and data output, we cannot justify whether the output is attained. So we go for the testing. If the testing is failed, we go for the alternation in our design part. So once the testing is done, the testing is purpose of hardware and software. So once the testing is done, we go for the high level design, and in the high level design, we go with the testing of block diagrams and data flow. So once the block diagram is confirmed and data flow is also satisfied, we go for the analysis part. In this analysis part, we will check whether our specification and constraints are achieved. So these are the bottom up approach. I'm going from the scratch to the top level. And in the testing stage, we should test the few things. First one is power consumption measurement, performance benchmark, whether the we are focusing on power, but when the power is minimized, it should not affect the performance. So we should also check for the performance benchmarking, memory access, wake up time, that is delay time, and functional verification. So whether my all the functions are verified. So I'm using this flow chart to navigate my testing purpose and to find out whether my overall application is attained. So here next main topic is memory organization and registers. So we have R2, R0 to R3, this is special function registers. From R4 to R15, it's a general purpose register, and apart from that we have status register and constant generator also. And this is a 16-bit address bus. Since it is a 16-bit microprocessor, the address bus is also 16-bit. We have RAM, ROM and other peripherals to share in between the controllers. And we have the instructions type. We have 27 core instructions in the RISC architecture, and double operand like we can use for move, add, subtract, and single operand is also available like INs, increment and decrement. Jump and call instructions can also be implemented. So you can see the sample instruction sets we have used in this MSP. So coming to the summary, MSP430 is a 16-bit low power microcontroller. So main reason for choosing it is it has multiple low modes for energy efficiency, and even though it is a low mode, it does not affect the performance. It gives the performance up to its benchmark. And coming to the instructions and memories, it is a 16-bit address bus, and it also comprises of RAM, ROM and other interfaces. And in our instruction set, we have 27 core instructions comprising of all the double and single operand. In the next lecture series, we will discuss about the application with regarding to this microprocessor. Thank you.